Hi, welcome to Peter Ericson's opinions on PostgreSQL. Well, PostgreSQL is a database, a object relational database to be exact. Whenever I'm talking about technology, I like to ask a few sort of basic questions. And the first one is, what can we use it for? Well, relational databases have been around for a long time. There's sort of been a movement, I guess, away from them in the recent decade. So, it is a fair question to ask. What do you need a relational database for? Well, I can think of one use case which is still valuable, and that's not that there's not others, and that's searching. So yes, you can substitute a database with a whole bunch of files on an SSD, sure, but then being able to search them and index them then becomes like a separate component that you have to maintain. Where if you use something like PostgreSQL, that ability and much more is already built in. So the second question I like to ask myself, when I'm looking at a technology is, where does it come from? Well, Postgres has a long history. It started in the University of California, Berkeley, in around 1986. It was at the time called Postgres, was renamed to Postgres 95, and then eventually was just renamed to PostgreSQL. I think that was in the 90s sometime. So it has a long history, and one thing I like about it is the documentation is very good. It's easy to access documentation for older versions, current versions. There's an option to do with and without comments. This version is static, so without comments. And I've found that the tutorial is quite nice. There's an overview of the language, a take on things from an administration point of view, how you would approach it from a client connection point of view. And there's a whole section on server programming. So how would you extend Postgres beyond SQL queries? All right. So finally, a question which seems obvious, but we can learn a lot from the process, and we can get sort of an idea of the complexity of the system, and what challenges you might experience if you choose to add Postgres to your own system. And that's, how do we install it? So today I'm going to install on a Linux and a BSD. This time I'm going to use the latest LTS Ubuntu, which is Xenial, and the latest OpenBSD release, which is OpenBSD 6. I've already done a Vagrant up, so we have our fresh VMs, but Postgres is not installed yet. I'm going to go ahead and run Ansible to install Postgres, and while it's working, I'll show you the playbook and the role. Alright, so while that's getting started, let's go and just have a look at what is a very basic Postgres Ansible role. Alright, so we have a top level playbook called PostgreSQL.yaml, and this is simply applying a role called PostgreSQL to two named hosts. The role encapsulates all the details about doing the thing, which is configuring Postgres. Right now the role consists of a single file, just a single playbook. And there's a little bit of repetition here. We're basically saying that if we're on OpenBSD, then we want to install the following packages: PostgreSQL Server and Client, and Contrib. Contrib are a set of extensions which aren't yet, or may never be, part of the PostgreSQL core. And the process is similar on Debian or Ubuntu, except that the one Postgres package covers both server and client. But like OpenBSD, the contrib package is a separate thing. Now, it doesn't hurt to add it. Any extensions that are provided through the contrib package are opt-in. Alright, so we're done. So at this point, let's just sort of log in and have a look. The topic of authorization and authentication. Now, Postgres has its own sort of concept of what a user is, what a group is, what a role is, which is separate from the operating system itself. So we will log into Ubuntu. The PostgreSQL client package comes with a command line tool called psql. If we just run it with no arguments, it's going to make a few assumptions. It's going to assume that your username is the same name that you've logged in as, and it will also assume that you're trying to connect to a database named after the username. Hit enter now. It's not going to work because it's going to tell us that the role, Ubuntu, doesn't exist. Now, when we first install Postgres, a Postgres role is initialized, and in PostgreSQL, Postgres is basically the root user. So if we were to go psql u Postgres, we might get a step further, or we might not, but we'll see. Now, what it's saying is, well, it didn't work, and what it's saying is pair authentication failed for user Postgres. Just for a bit of an overview of what types are provided. Now, we've already seen a message to do with pair. There's also trust, which is similar to pair, and I'll get to why it's similar. We can offload authentication to PAM or LDAP or Radius or ident. GSS API would be how you would go about using Kerberos if you want to integrate with a Kerberos or Active Directory domain. And then there's various forms of password authentication as well. So the reason why pair authentication doesn't work is because our user is Ubuntu, and because we're on the same machine as the server, in fact, pair and trust only work on the same machine as the server can tell that whoever ran this client is not actually Postgres, it's actually a user called Ubuntu. So what we'll do is we'll go ahead and change user to Postgres. We'll run that command again. This time we don't have to specify -u because it will default to the user Postgres. Just to make sure that's really true. Let's see, that's how it works. So now we have, we're logged into PSQL, but we won't go any further right now. We'll come back to PSQL in just a moment. We're actually going to have a look at the configuration for authentication to Postgres. So if we go into PostgreSQL and then a directory named after the major version, 9.5, main, there's a file called pghba. There's also PostgreSQL.conf, which has interesting things in there, but we probably won't look at that this time. We would look at that file if we were interested in tuning Postgres to, say, handle more client connections, but that's not something we're going to cover this time. What this file does is defines who can connect and under what situations. This is more about who can connect to the Postgres server itself. Once you're connected, then you're sort of at the mercy of the roles users group system that's built into Postgres. So this is all about making that initial connection. Now I'm just scrolling down. So first of all, we've got a line that says local users can connect as the user Postgres if they're using the authentication method pair. Cool. Now I mentioned trust before. If this was trust, which used to be the default a while ago, maybe several years ago, maybe 5 or 10 years ago, it wouldn't check your local username. It would just assume that if you're a local user, that's good enough, basically. So we're also saying all users, so if you're not the Postgres user, you can connect via peer as well, which is all good. And if you're connecting via TCP from localhost, then you have to connect with a password, and the password has to be sort of hashed with MD5. If we wanted to allow remote access, then we'd have a line fairly similar to this one, except that would be providing either a specific subnet or something wide open to any incoming address. Now at this point we've sort of left OpenBSD behind a bit. OpenBSD doesn't actually configure the database for you out of the box. A little bit of extra work is required, which is both good and bad depending on your perspective. We will cover that quickly because I think it gives us some interesting insight into the system. So I'm root in my OpenBSD VM. If I have a look at user local, this is just a file that's named after the package. This will tell us some information about how to get started. Very basically, we just need these commands here. It might be worth specifying an encoding. Alright, so what do we need to do? We need to su to the _ PostgreSQL user. We need to make the var directory var PostgreSQL data, and then we need to initialize the database itself, so the data folders. We can follow this method or we can follow this method. Now I'm going to give it a very weak password, and there's a reason why I'm going to give it the weak password. Number one, we're not allowing external connections to Postgres. Number two, there are some tools that we might want to play around with, which will make the assumption that the user is Postgres with password Postgres. But obviously, if this was a production system, you'd want to choose a very strong password for your Postgres user. So I'm going to enter Postgres again. Now, at this point, the initial database is initialized. There is some instructions here on how you might start Postgres, but we have an easier way to do that now. We can use rctool to enable PostgreSQL. This will ensure that it gets started on boot, like it would under Debian or Ubuntu. Sorry, I'll just need to drop back to root. And we can start PostgreSQL. So I think if we drop back to our regular user, which is Vagrant, let's see if we can connect to Postgres already. So there won't be a user called Vagrant. Okay, so here straight away it's asking us for a password. Now, I'm not going to try and log in as Vagrant because I know that user doesn't exist, but I can try and log in as the Postgres user. I'll enter the password that I specified when I initialized the database, and yes, so that worked. So we can see here that this initial configuration is a bit different between Ubuntu and OpenBSD. So let's go and have a look at the pghba conf file. See if we can get some clues there. Okay, for a start, there's no etc PostgreSQL, but from experience, I believe that on Debian / Ubuntu, that's actually a symlink into var lib, or in this case, var PostgreSQL. Let's see. I think that's not quite right either. Well, it must be somewhere. Oh no, I can see it there. All right. So in data, there's a file called pghba, and again, we won't look at PostgreSQL.conf this time, even though that will be key to talking about performance and tuning. So let's scroll right to the end and see what we have configured out of the box. So I think because we did that initdb command and specified MD5, we're seeing MD5 across the board. We're seeing that any local connection for any user must authenticate with a password that's hashed with MD5, and similar for any TCP connections from localhost. Now, just like on Ubuntu, it's not actually configured to listen to connections from external, and that's fine. Right, so at this point, we've talked about installation of Postgres, we've talked about authorization, authentication. We haven't actually talked about the internals of how the users, groups, and roles work, but we've covered how you connect to the database itself. If we go back to psql, and I should say at this point, from now on, what we do on OpenBSD should be identical to Ubuntu. So let's log in. Now there's some commands for listing various things. If we go \, it will list them. This used to be sort of burnt into my brain, but it's not anymore. If we do, I think /d will show us tables. So in this database called Postgres, there are no tables, so that's why it's not showing us anything. We actually want to list databases, and I've just forgotten what that one is, so let's have a look. List databases. Okay, /l. And for a lot of these commands, if you do plus at the end, it will give you some extra information. That's scrolling off the edge of the screen, so let's go back. Okay, so there is the Postgres user database, which is empty. While we're here, we should talk about what template 0 and template 1 is. So every time you create a new database, it will basically take a copy of template 1. So that can be quite handy. So say there's some conventions that you want in every database, you can actually modify template 1 and they'll be sort of copied across when you create a new database. Template 0 is similar, except that you cannot change it. So that gives you the chance when you create a database to decide, do I want to create it from template 0, which I know cannot be customized, will not have been customized, or do I want to create it from template 1, which may have been customized in some way. And things like the encoding also come across when you create a new database. Another thing I was going to talk about, which is probably a little bit premature, but I think it's important. It's important to some people anyway. When a client connects to database, to PostgreSQL, a single OS process is spawned to handle that connection. Some databases like MySQL have a threading model where a client connection will be a thread. In theory, it's more scalable, right? Because threads are lighter weight than processes. There's some nuances to this because threads have a shared memory structure. They're not quite as easy to distribute between cores on a system. So just because threads are used doesn't necessarily mean that it's going to perform faster than a per process model, although it probably will, but yeah, I'm just saying it's not a given. We've probably covered enough for this talk. The more interesting part of this will be creating tables, importing data, and then looking at what kind of indexes we can create to search that data. Well, actually, no. We should do at least one query, right? So we've gone to all this effort to install Postgres, and we haven't made it do any work at all. So here we go. Select 1. We've selected the value 1. If you found this useful to you, please like it. If you'd like to see other videos, more opinions about technology from me, you are welcome to subscribe.